Well, hello students, welcome back to Math Specialist class with me, Mr. Alfie. In this video, we're going to learn about scalar product of factors. Let's check this video out. Scalar product of factors. Let A and B are factors and the components of A are x and y and components of B are m and n. A dot B is actually xy dot mn. How to find the product of these two factors? You just need to multiply di with di and the j with the j, and you add those numbers together. So A dot B is actually xm plus yn. Let's jump to the example. Let's A is the factor that have components 2 and negative 1, and B the components are 3 and 4. Determine A dot B. A dot B is equal to 2, negative 1 dot 3 and 4. We just need to multiply the i's. 2 times 3 is 6 and the j's. Negative 1 times 4 negative 4, and we add those numbers together equal to 2. Let A and B are factors and theta is the angle between the factors. The other formula to find A dot B is actually magnitude of A times magnitude of B cosine theta. Remember, theta is the angle between the factors. Find the angle between A and B given that A 5i plus 2j and B negative 3i plus j. We know that A dot B equal to magnitude of A times magnitude of B cosine theta. And we know that the other formula of A dot B. A dot B is 5 2 times negative 3 1s from the components of each factors A and B, equal to the magnitude of A. This is the magnitude of A, square of 5 square plus 2 square from the component of A, and this is the magnitude of factor B, negative 3 square plus 1 square from the components of B, cosine theta. We know that this dot product is actually 5 times negative 3, negative 15, 2 times 1 equal to 2. This is square of 29 times square of 10 cosine theta. So, negative 15 plus 2 equal to negative 13 equal to negative square root of 29 times square root of 10 is square root of 290 cosine theta. So, cosine theta equal to negative 13 per square root of 290. By calculator, you find anti-cosine of these numbers, then you'll find that theta is actually equal to 139.8 degree. Next example, let's A, this the component, B, these are the component, and Y, unknown the component, let's say mi plus nj. If A dot y equal to 9 and B dot y equal to negative 1, determine the value of m and n. Let's work from this one first. A dot y equal to 9. It means A dot 9 equal to 5 2 times mn. This is the component of A and this is the component of factor y. So A dot y have known from this one equal to 9. So 9 equal to 5 times m, 5m, plus 2 times n, 2n. We find the first equation. Now let's work with this one. B dot y equal to negative 31 dot mn. This is the components of B and this is the component of y. We have known that B dot y equal to negative 1. So negative 1 equal to negative 3m plus n. We find the second equation. After we have found the first equation and the second equation, by elimination, we will find that the value of m equal to 1 and the value of n equal to 2. Factor y is mi plus nj. So factor y equal to I plus 2j. Next, if A and B are perpendicular, it means the angle between A and B, the theta, equal to 90. So A dot B equal to magnitude of A times magnitude B times cosine theta. We know that the cosine theta equal to cosine 90. Cosine 90 equal to 0. So A dot B equal to 0. Then, if A and B are perpendicular, A dot B equal to 0. Given that factor A and B are perpendicular, simplify the expression below. How to simplify this expression? First, we need to expand this expression. A multiple with all the component here and 3B multiple with all component here. We expand the expression, we'll get this expression. A squared minus 2 dot 2b plus 3b dot a minus 6b squared. We can arrange the expression, become this one. We know that A and B are perpendicular, so this equal to 0 and also this one. 2 times 0 equal to 0 and 3 times 0 also equal to 0. So the simplest form from this expression is become a squared minus 6b squared. Next, about position factor. Let the position factor OA 4, 2, OB negative 1 and 1, and OC negative 3, 6 give the coordinates of triangle ABC. Show using a dot product method why triangle ABC is a right angled triangle. So we need to prove that triangle ABC is a right angled triangle. How to prove it? The triangle ABC is a right angled triangle. This is the illustration. A right angled triangle has a one angle that equal to 90 degrees or the right angle. So we have to find one of the angle that form this triangle equal to 90 degree or right angle using the dot product method. We know OA, OB and OC. A dot B is 4, 2 dot negative 1, 1 equal to negative 2. So A dot B not equal to 0. It means A and B don't make a right angle. How about the other? B dot C is negative 1 and 1 dot negative 3 and 6 equal to 9. 9 is not 0, so B dot C isn't equal to 0. That means B and C don't make a right angle triangle. How about C and A? C dot A equal to negative 3, 6 dot 4 and 2 equal to 0. That means C and A make right angle. It means C perpendicular to A. It is proof that ABC is a right angle triangle. Why it is proof? Because one of the angle is actually right angle, or one side is perpendicular with the other side. Next, AOB is a diameter of a circle. The center is O. This is the center. It means AO is the radius and either with OB, also the radius. C lies on the circumference of the circle. This is C. It means OC is also the radius. Factor OB equal to factor B, this one, OB in this direction, and OC, factor OC equal to factor C, OC in this direction. Using factor method, prove that the angle ABC is a right angle. How to prove that ACB is a right angle? We need to prove that CA is perpendicular with CB. How to prove that they are perpendicular? Their dot product equal to 0. So they can be perpendicular. Okay, we know that OB equal to factor B and OC equal to C. This factor and this factor. Now, look BC as a factor sultan. So BC a factor sultan of BO plus OC. BO is negative B because they are the same factor but different direction. OC equal to factor C. So factor BC equal to negative B plus C. Now, look at a factor CA. See factor CA as a factor sultan. Factor CA is a factor sultan of CO plus OA. CO plus OA. We know that CO is actually negative C because CO is the same factor with C but opposite direction. And factor OA is actually the same factor with OB because they both are the radius, but OA is different direction of OB, the opposite direction. So OA is negative B. So CA equal to negative C minus B. Now we're going to prove that CA dot BC is equal to 0. CA dot CB is negative B minus C dot negative B plus C. You just need to expand this expression. You will find that P dot B minus B dot C plus B dot C minus C dot C. You can make it simpler because this is equal to 0. So AC dot CB equal to B dot B minus C dot C. We know that B dot B equal to magnitude of B dot magnitude of B times cosine theta and also the C. B dot B cosine 0. The theta between factor B and B is 0 minus C dot C cosine 0. Why the angle between the same factors is actually equal to 0? This factor B and B, this factor C and C. Let's see. This is the factor B. And we make another factor B and place it close to the factor B. They are actually fit one with the other because they are actually the same factor, the same direction and the same magnitude. So B and B fit each other. It means the angle between B and B is equal to 0 and the same trait with C and C also equal to 0. So cosine 0 equal to 1. AC dot CB equal to magnitude B dot magnitude B minus magnitude C dot magnitude C. From this, you know that B is actually the radius and C also the radius. So B dot B and C dot C is actually R dot R and R dot R. So AC dot CB equal to R dot R minus R dot R equal to R square minus R square. This is equal to 0. Because AC dot CB equal to 0, it means AC perpendicular with CB. Because they are perpendicular, it means angle ACB is a right angle.